Okay, friends. So was there anything that you saw on the homework that you wanted to go over? A couple things I saw. I do appreciate, color coding, but just, you're not wrong if you do this, but I just want to point it out to you that sometimes the color coding can be used to influence, and you don't necessarily want your information. Though I like it. Don't get me wrong. I like the color. So I'm not asking you not to use it. I'm just, as you progress beyond high school and you're reading stuff, realize sometimes that color coding, think of it if they had real vibrant colors on the stuff they wanted you to know, and then like barf as a color on which they don't want you to know. So, and again, you're not wrong for having the colors. I just want you to just be aware that sometimes the colors are used to impact. Other times it might not be. If you were, I think the example we did the other day, we talked about different high schools. If you had like the high school colors as part of it, I don't necessarily think that is a influencer. But if you weren't looking at stuff that had like colors like that related to school colors, I think that you might be able to impact your reader, which sometimes that might be the what you're trying to aim towards. I want people to think this, therefore I'm going to have the best colors ever. All right, so was there any questions you saw? And then also, if you are here and you didn't get your homework done, I'll put a 2 out of 4 in and then turn in the next day and you give you a 4 out of 4. If you're absent, I'll put a 0 in, but please get it done and then show me you can get the 4. Does that make sense to my method, to my madness? Okay. If you choose to keep the 2 and you don't do it, then you keep the 2. I'm not going to impact the grade, in a positive way if you didn't do it. But if you are here because we go over so much of the work, it's very possible that you could do it. And if you get it done, just show me the following day, get the 4 out of 4. And that's pretty cool. So, but no other questions there. So let's review a little bit. So the graph we used was called a what? Bar graph. Okay, and this is going to lead into our notes. So the bar graph, basically, you had an XY axis. You have both labels. This is a numeric value, and this is some sort of category. Number of students that took the ACT, number of students that took the SAT, number of the students that took the ASVAB, some sort of category is on that. And then you have to make sure that your widths, the width of this, all the widths have to be the same. All of the separations between the bars need to be the same, and I realize my artistic and representation, all of the distances should be the same, but because I'm just drawing this freehand, I can't do it. But if a computer will do it for you, don't force the computer to change. So a bar graph is a way of looking at categorical data where we're counting up. Theoretically, mathematically, it should start with a 0, but then this would be, label A, B, or C, where A, B, and C are any things that you're trying to count up. Okay, it's just a way of looking at data. It's not anything that's made for conclusions. And that's a rough thing sometimes with statistics. It's like, hey, we're seeing this event, therefore everything must be that way. That's incorrect to think that way with statistics, especially as we progress and learn how you collect data. You ask a question, you look at your data, how it reflects that. You test something called the null hypothesis, and then you're looking at something called a p-score for overall. There's different tests you use, but the most common is the p-score. And again, we'll get there. That's like, so far away from us right now. So a bar graph looks like that. But here, I want to do a side-by-side. And I'm not going to put any labels on it. I'm just changing color so it's a different tone that you're looking at. So this is a bar graph. The one next to it looks very similar. But what's kind of a difference that you see looking at it between the two, other than my artistic ability and one's blue and one's green? Yeah?
The bars are together
Yeah, the bars are together. They're touching. So what we're going to talk about today is called a histogram. And of course, I'd be a much better teacher if I knew how to spell Histo. Okay. Now, a histogram looks very, very similar to a bar graph. People say, oh, it's a bar graph that just touches. Yes and no. So between these two, let's look at the similarities. You have a numeric value on the y-axis on both. This one is some sort of category label, meaning like, let's take 5 different fast food restaurants, and we could label those down here as A, B, and C. Whereas this one on the histogram, you have a certain, first off, all of the widths on these all have to be the same, just like on a bar graph, even though Stirrup can't draw appropriately. But you have a numeric value down here as well. Okay? Where you start seeing histograms, and histograms, again, they depending upon how you do it, can indeed impact how your reader will portray your data. Okay? So let's go to a histogram, and let's take, I'm just going to make this up. This was Stirrup's, that's me, last year CP Algebra 1 grades. Now this is just purely fictitious. This didn't really work. These grades might actually impact a higher amount than I actually had. And normally if they give you a list, it won't always be in order. But I'm going to put it in order because that's easier for my mind to think. Okay? So let's say we had 41%, 50%, 53%, 57%, 61%. Now we'll just call these all percents rather than writing it down. 68, 70, 71, 77, 80, 83, and then 96. Okay? And again, I'm just making these up. These are just arbitrary semester grades. Could my grade book have looked like that? Sure, but I just made it up just for the purposes. So a few things. We want to create some sort of histogram. And we have to figure out how wide each one of our bars will be. Now, if I draw into my histogram, we're going to have this be percent score. And then we have to figure out how many rectangles we want. Okay? And what's the perfect thing? Some people say, well, 5 would be great. Some would say 10. Some would say 20. But you're going to get to a point where you have too many bars of it to look at your data that it'll be meaningless to take a look at it. So let me just ask you, my friends, what do you think would be an appropriate width of each of our bars? And you're not going to say a wrong answer. We can just kind of think about it, how you want to do it. Should we have them as singleton, each bar is 1%? That might be a little too much. Should they all be 2%? Should they be 50%? Being I have 2 bars, 50% on one side, 50% on the other. I mean, they're all representing data by what we're saying. 10% I think would be nice. 5% might be a little too much to look at, but it would also represent our data. So, you know, the rule of thumb on it is if you take a look at your data and it divides nicely into a number, great. I would say try and have at least 10, but no more than 20. And I know that might be a little different than what's in there because there's not really, you know, the school of statisticians, you know, if you have this many, you have to divide by this and square root it, and that's how many bars you have. I don't think they have that kind of rule. Okay, so I'm going to lay this down so I can draw it a little neater. So if we break it up by 10%, get 0 here. I don't know, I'd say that's our full range of scores that we could have. And then we decided each one will be 10% width, okay? And then how many percent scores do we have in each region? Okay, so we have to figure out what we want to count our y-axis at. So it looks like we have 3 in the 50s, 2 in the 60s, 3 in the 70s, 2 in the 80s. So we could look at the data on our y-axis. We could say we can maybe go from 0 to 10. Maybe we can go from 0 to 5 because it's just a counting principle that we're using. So just to make it different than our other one, let's say we're going to count so that's how many particular scores. So do I have any scores that are from 0 to 10%? Nope. So don't put anything. I mean, some people might say, oh, I could do this. And sometimes that could be misleading because you're like, well, do I have like one score? Well, no. I guess you could do that. It might be okay, but it might not be necessary. I don't have anything from 10 to 20. So I guess we could keep doing that if we wanted to, just so we know we're filling in the regions. 20 to 30, don't have any. 30 to 40, none. And then I have a 41 in there. That's my first one. Agreed? So we took care of that. I have 3 scores in the 50s, so between 50 and 60. So that's 3 scores. Took care of those. 2 scores in the 60s. Now we get to kind of a goofy. What's special about that 70? Yeah, it's right on the line. So should it be in the graph to the left or should it be to the graph to the right? I guess it depends who you want to impact. And that sounds kind of funny. If I put it on the graph to the left, it would look like we have the 60 to 70 range looking kind of bad. If we keep it to the right, it's going to impact our 70 region to look a little nicer. So I have 1, 2, 3 there. So it should be the same height as that first one. So I'm going to say that this fell into this category, which is totally fine, as long as you keep it consistent. So now we have those 3 scores. Now we have an 80. The 80 should go to the one to the right because we had the first one, the 70, stay to the one to the right. So we have 2 scores there. And then we have 1 score in the 90s. Okay? Now, do you know, just by looking at the graph that's up there, do you know what scores were there if you weren't looking at the percents? Or you just know that in each of those bars, there's a certain number of scores. Those scores could go to the right from a 40 to a 49.999, or 50 to 59.999, to 60 to 69.999, 70 to 80, 79, and keeps going. So it's just your counting. You don't know actually where your scores are. If you went and said, hey, I have a score that's in this region here, but you just know the score is in that region, you don't know exactly what your score is other than it's more than 50, but less than, or it's 50 or more to 60, 50 to 59. Okay, as full percents. Oh, I'm sorry, I'm getting in the way. Hey! Does that make sense? Kind of straightforward. Okay. Does anyone else show that? Inch. That's not here. Okay. All right, so now let's talk a little philosophical. why would people or organizations change what data would look like? What's really the agenda of organizations that, let's go with political organizations. I'm not saying I'm saying one side or the other. Let's pull the politics in. Now, I think we are all okay to say that there's some people that can't stand the left, there's some people that can't stand the right, and then the majority of the rest of the people are somewhere in the middle of everything to say, I support some ideas on one side, support other ideas on the other. I mean, I think that's kind of society. But you will get people at the very far right, and you will get people at the very far left that are just passionate about what they want to tell people. We've seen it, and my goodness, we have memes all over the place that are awesome to look at, right? You get it from both sides that are making fun of both sides, and it becomes just sheer entertainment for us. Now, again, my friends, I'm not trying to bring politics in my class, but we've seen this quite a bit. And I'm not trying to make fun of things. I mean, don't get me wrong. You send me the right meme, I'm chuckling. Okay? I think there's things that are funny out there, but I'm not being swayed by the population. Now, prior to social media, we had rumors. Now, the only problem is your rumors that you all came across become like nonstop in your face on your phones or your devices. But I remember in school there would be, oh, there's a rumor that this kid, blah, blah, blah. And that would go away after you hear about it. Oh, man, that's kind of crazy. But then you realize. But could I make this look like a different graph? And the answer is yes. And so let me take the same data. I'm going to erase this part of my region. Come on, erase a little better than you're doing. Okay, so I'm going to take the exact same data, but I'm going to create it on this. Okay, so I'm now changing the y-axis to 0 to 10. Okay. Maybe I change this. Both histograms, agree? The bottom one makes it look like Stirrup's a pretty good teacher. The one on top, I guess, looks okay, but look at the bottom. You had more kids to the right of 50% than you had to the left. Oh, he must be a good teacher. He cares. Of course I care. I don't think it makes me a good teacher because I changed my X and Y axis. But can you see how there might be a little bit more of an impact? Heck, I could change it. I could change my y-axis. How many pieces of data I got in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I could count this up to 12 and go from 0 to 100% and just show one rectangle. Yeah, everybody gets a trophy, right? Huh. What do you think? Could this kind of information be used inappropriately? Could it be used because somebody doesn't necessarily understand it and they just say, oh, this must be right, therefore it should be? And then could there be organizations out there that are trying to use, and granted, Stirrup CP Algebra 1 class, the data is pretty boring. It was made up, it's fictitious, but it doesn't mean anything. But could we have looked at other things to influence it? And absolutely we could. Other ways that these could be done incorrectly is, let's say I like this region here, so I actually make this as a 3D model. This looks wonderful. And let's pretend I can draw really good and I can shade it in. In fact, I show a shadow that goes with it. I don't know. There's all kinds of things that people think, oh, the more creative I get with these, the better people are going to like it. We like things that are easy on the eyes. Okay? Y'all know why some people have a better or a prettier or a more attractive face than others? It has to do with the symmetry of their face. Like this guy, man, if my dog had this face, I'd shave my dog's butt and make it walk backwards. I don't have symmetry to my face. I got one nostril bigger than the other. I got this butt chin, one side's more bigger than the other. I think my eyes are almost symmetric, but my nose isn't. But it has to do with symmetry. So how could people make me prettier? Well, I imagine this is an app that is out there, or if it's not, it's going to come, is you could take a picture of anybody's face. You could do the cross section here, do the reflection of one side of the face to the other, and you're going to look a lot better. You're all beautiful people, don't go home saying Mr. Sherp says we're ugly because we're not symmetric. No, but if you were to take a cross section from your forehead all the way down to your chin and then reflect the left side to the right side, and that's the image you look at, or the right side to the left side, one, you're going to look very similar to what you look at, but you're like, wow, I look even better. It's not because you're ugly. It's just because the symmetry. If you go and you look at some of the supermodels out there where you're like, wow, that's a very attractive male or female or person, it's mainly because of the symmetry. And a lot of times they can shadow makeup to allow the symmetry to appear to be taking place when it's not really. Oh, wait, this is a little misleading with life. Oh, he just told us all these things. All right, let's see. I'm just looking at the notes real quick. I haven't based in too much off of it. Clear tuck marks labeling both the axes we talked about. The width of the bar should be identical. We talked about that. The vertical axis should generally begin with 0. Okay. The area under each bar must be proportional to the data displayed. The bars should touch. It helps visualize a left-right flow with data. Unlike the bar graph, the order of the bars is important. For example, we can see that on the example there that you have a peak with your data. This doesn't appear to have, it has two different peaks. Sometimes I might say that there is, it's a bimodal type of thing, but you don't have to know that term yet. And then down at the bottom of page 8, it says, how many bars should a histogram have? And then they don't really answer it well for us. It says there's no easy answer. If there are too few bars, it hides a lot of useful information about the way data is distributed. If there are too many bars displayed, it can appear confusing. And then mathematicians have attempted to create formulas to determine the number of bars a histogram should have, but these formulas are flawed. The truth is the number of bars is dependent on the general shape, the distribution and possible presence of usually high to low values. We will usually use between 5 and 10 bars in here. And so it just becomes, make it easy to divide. Make it easy for your data to fall into. Okay, could we have changed that to 0 to 5%, 5 to 10, 10 to 15, so on? Absolutely. And I'm not going to do it because I don't want to write that much, but I'm just being honest with you. But there's just different ways that you can represent the data where one looks kind of good. I mean, I think this top graph looks relatively nice to look at. This bottom graph, obviously me making the 3-dimension of the right side, really makes it bad, but I think it was bad altogether in the beginning, just showing two different things. It shows that there was either a yes or no or a true or false responses. Granted, we have more responses than that in our data. Okay, so What time we have here? Don't lie, because I'll find out when the clock. Okay. So I think this is what I have planned for tomorrow. And I haven't decided 100% of what I want to do with tomorrow. Oh, come on, come back. Turn back on. Let me get to the assignment. It's 90 something. Anyone have it there? 101? Okay, so let's just take a look at this. 101. Okay. All right. So I'd like to do page 101 or 100 or 101 to 102. That'll be for tomorrow. And this helps me. Then tomorrow during class, tomorrow's Tuesday, we will go through and talk about how the review works. So page 101, 102 is for tomorrow. Tuesday, we will go over the homework as well as the review itself. Wednesday, we are going to have a quiz from 1.1 to 1.3. And I will just say this. Every quiz I give, you are allowed to put whatever you want on a note card. And you can use a calculator. No, you can't use photo math. We'll do it Wednesday. But anything from 1.1 to 1.3, including what we go over tomorrow with a review, if you ever have a note card. If you need a note card, let me know. I have about 255,000 of them.
You said 101 and 102.
Yeah.
Tonight.
Yep.
And then I did finish the other one.
You finished the other one?
Yeah, I don't know if
What's your last name?
Heartbreaker.
Okay.
HA.
H.A. You got it. I'm going in with it. And anybody else finish the homework that I need to be aware of? Okay, hang on. Let me get the first one in. What's your last name? You got it done as well. Works for me. Anybody else got it done that I should know about? Hey, my friends, do any of you need to go and get the book? You got $5 with you? Go grab it. Go get it. If you leave your stuff, go grab the book. I'll make sure no one touches your stuff.